Hi, I'm Pablo Sainz. I'm a student of second year of Bachillerato in Sumaldapeta, and I'm gonna explain you the exercise that I have chosen for the physics optative work. In my case, I have chosen an exercise from the fourth unit of the first term of physics book. For this work, I have used an Excel and a GeoGebra to show you the results on a dynamic way. Well, my exercise consists in a spring that extends 0.6 meters when it's loaded with a 10 kilogram mass. Then we add another mass of 150 kilograms and give a 5-meter downward pull and starts to swing freely. Find the speed after 10 seconds the movement started. The variables that I have chosen are the elongation, the d1, the second mass, the amplitude, and the time. Depending on them, the speed changes. According to the first variable, which is the m2 that varies from 130 to 220 kilograms, we can see that when it's becoming bigger the mass, the speed becomes slower. If we try it in the GeoGebra with 130 kilograms, for example, we can see that it goes much faster than if we put 220 kilograms. And that happens because the M2 is used to get the pulsation. Okay, so the second variable that I have chosen is the d1 distance. That is the distance from the top to the bottom of the spring when we add the first mass to the spring. In my case, it varies from 0.6 to 0.69 meter, and in that period we can see that when the d1 distance is longer, the speed is smaller because d1 distance affects to the spring constant that is used to get the pulsation, so both change. In my GeoGebra, we can see it very well because the d1 period is small. But for example, if we put a maximum of 2, we can see that it goes much more slower. In my GeoGebra, I have used these start and stop buttons that allow you to initiate or stop the simulation, which are very helpful and easy to create by clicking in this button. Continuing with the variables, we have the A amplitude variable, which as we can see in this graphic increases linearly with the speed. I have used the amplitude from 5 meters to 10 meters and increases 0.5 each time. The amplitude increases linearly with the speed because as we can see here it's in the formula and it's directly associated with it. If we try in our GeoGebra changing for example an amplitude of 5, we can see that the maximum of speed is for example 4.42, but with an amplitude of 10 the maximum is 8 point something. The last variable that I have chosen is the time, and it varies from a period of 0 to 9. By doing this we can see that it's a sinusoidal or senoidal function and changes the direction every 3 seconds. If we try here in the GeoGebra, when it reaches the maximum or the minimum, start to change the direction, and it would be this sinusoidal function. Well, to finish this work, I have to say that with this video, I'm gonna include the GeoGebra so you can try it, the work page, and the Excel. This has been everything. I hope you have learned how it works. Bye bye.